Okay, in this problem from section 3.1 Openstax Calculus Volume 1, we are going to find the derivative of a function at a. We have different uh, definitions of derivatives that we can use. I am going to use this one that is f prime of a equals the limit x approaches a f of x minus f of a. Some people never want to use this. They want to use a different one. But for this problem, I'm going to use this. I think it's a little bit more direct. Here we're finding f prime of 2 because as it says, a is 2. And I replace a by 2. Wherever I see a, I put in 2. And then wherever I see f, I'm going to replace that by 1 over x. But in the next one where I have f of 2, I write 1 over 2. I put 2 where the x goes. And now this is a complex fraction, which means it's a fraction inside of a fraction. Some people call it that. It has nothing to do with complex numbers. It means fraction inside of a fraction. And so what I do to solve this is I multiply, or not solve, simplify, is I multiply the numerator and denominator by 2x because that is the common denominator of 1 over x and 1/2. And by doing that, what happens is I use the distributive property and then I cancel. It's a pretty direct way to do this. 2x times 1 over x is 2. So 1 over x times 2x makes 2. 1/2 times 2x makes x. And then in the denominator, I'm not going to multiply out or use the distributive property multiplying 2x times x minus 2 because I want to cancel the x minus 2. And my little trick here now is that I want to reverse the order of that difference. I have 2 minus x. I want x minus 2. In order to do that, I just multiply. I just factor out -1. Factor out -1 there. And so there's cancellation. And so I have limit x approaches 2 of -1 over 2x. At this point, I can go ahead and plug in 2 for x, and I get -1/4. And at this point, it's tempting for me to sort of get a little bit carried away, and I guess I'll do it and sketch the graph. There's nothing here says I need to sketch the graph, but I'm thinking, well, why don't I anyway? Well, because it takes up time, okay, but maybe I'll sketch the graph. Not just time, it's taking up space on the page here, but okay. So we're looking at y equals 1 over x, and part of what I think is good is if you memorize these so-called elementary functions. So, the graphs of these elementary functions. At 2, the y coordinate's 1/2. I mean, we saw that when we put in f of 2. See over here, f of 2 is 1/2. So we're looking at this, we look at a tangent line there at 2 1/2, and the slope is -1/4, which I could see myself having a little trouble doing that, but I think I can do it. It's going to look like this. So, I mean, so it makes sense, but it doesn't the way I drew this. It doesn't. It should look more like that. And in fact, my tangent line is is correct, but my drawing was a little bit imprecise. So something more like that. Okay, no, that's not going to do it. It's okay. Anyway, so I think that's good. I'm trying to think. Actually, isn't good? I think that's all right. Yeah, I think that's exactly it. So okay, so that makes sense, and it wasn't required to do that anyway, but I did it just to add to this. I mean, it's a check, right? You want to check a little bit to see whether the answer -1/4 makes any sense for a slope. So this right here is, well, okay, maybe I didn't make that clear. That's the derivative, but the derivative is the slope of the tangent line. And so that's why I'm sketching the graph and I'm looking at this and seeing, okay, is -1/4 make sense? All right, so, I mean, I think it does. Okay, so that's all.